This is our third elementary flow known as doublet flow. It is a special degenerate case of source and sink that leads to a singularity known as doublet. So doublet is a combination of a source and sink of equal strength. Remember, if that lambda is the strength of the source or sink, which will be placed at a distance 2L along the x-axis, and subsequently they will approach to each other, and we will derive the stream and potential function for that flow. Now next we will go and obtain the stream function for the doublet flow, and for that purpose consider a source and a sink placed on x-axis. They are placed at distance 2L apart from them. Now consider a point Pxy, an arbitrary point. The distance of this point from the sink is r1, and angle which is making that is theta 1. The distance from the source is r2 and the angle is theta 2. Now it is critical that the sink and source will approach to each other. So these distances will ultimately be from the origin, which I will keep as an arbitrary distance r, and this is my origin. Moreover, I have indicated some distances with the help of right angle triangle laws, and these distances are, you can easily obtain that. So this distance I am calling it 2L cos theta 2, and this is I'm calling B distance. So next we will go and write the stream function for this doublet. Now I will determine the stream function for the doublet. From geometry, you should notice that the difference of angle is theta 1 minus theta 2. This difference of angle I have indicated in the previous figure with blue marker. Now I will write down the stream function for the doublet, which is a combination of stream function of source and a stream function of sink. Subsequently, I have substituted the values of stream function for source and sink. Make sure source is at angle theta 2 from the point P and sink is at angle theta 1 from the point P. So after the simplification, I have obtained this relation for my doublet. Now remember that I mentioned that both sink and source are approaching to each other. So if they approach to each other, then the angle that they are making, which is theta 1 and theta 2, will be approaching to theta. And similarly the radius, the distance, and the distances are also approaching to r. Subsequently, I will utilize further details of the geometry to simplify my stream function. Now consider previous figure, and from the geometry I can further write down the difference of angle delta theta in terms of tangent inverse A over B. So this is perpendicular and this is base of that triangle, and B has been subsequently replaced by this relation and A with this relation. Further simplification I am introducing here, since my sink and source are approaching each other, therefore the delta theta becomes very small, and for a small value of delta theta I can write down tangent of delta theta equal to delta theta. So using this I can easily write down my previous equation like that. So in this equation there is no tangent because of small values of delta theta. Now substitute this value of delta theta in the equation of a stream function that I have previously set for my doublet, then I will obtain this equation, which can further be simplified. Now I have introduced further simplification in the equation of a stream function. As L is approaching 0, this theta 2 will be theta, R2 will be R. This term I am considering as a constant, kappa, and this term will be approaching 0. So once I have that, I have obtained the equation for my stream function for a doublet. So this is my equation for the stream function of doublet. The doublet located at origin and pointed along the negative x-axis. Here are some details of the doublet I would like to summarize. As you have seen that the equation that we have obtained for the doublet, this is a stream function, and this doublet is located at the origin pointed along the negative x-axis. We can also say that pointed to the left, because you see that the streamlines are emanating, going towards the left direction from here. So if I change the sign from negative to positive, then it will be opposite direction. Now moreover, you can also determine the radial and tangential velocity at a particular point in the doublet flow field using these relations, and make sure these relations will always be utilized if any stream function is given in polar coordinates.